Cool. Thanks, everybody. So today I'm going to talk a little bit about how to use Jupyter for education and teaching people. My name is Moshe Zadka. My website is cobodism.com, where you can find every way of reaching out to me known to humankind. I do want to start with acknowledgement of country. I live in Hayward in San Francisco Bay Area, which is the ancestral homeland of the Ohlone people. This is a talk about teaching. So I should probably talk a little bit about like how I think about teaching. I've never been a full-time teacher, but I have taught professionally. I mean, I have received money in return for teaching people. So I feel like I can talk a little bit about that. But most importantly, I want to talk about, I don't have a time machine. Probably some of you also don't have time machines. So any information I can impart to you hopefully will be useful for you in the future, but probably not in the past. So when I talk about teaching, I'm going to be talking about teaching in the context of 2023 and onwards. So what does teaching look like in 2023 and onward? Right, we live in a world that's very different than the world even a few years ago. Right, and like the way I like to summarize it, we live in a hybrid world. Right, until say 2019, when we thought of teaching, well, some people did do stuff like remote. The main thing that we did as teachers was, what I'm doing right now, spoke in front of people who are there in person, which is great, right? It's wonderful. Then, for a little bit, we didn't do that at all, right? For more or less of a year, depending on your exact circumstances, all of us did remote teaching, right? We were doing someone was sitting at one place, and most of the students were sitting at various other places, and the only communication they had between them was using the internet, right? Which was not maybe great, especially like how fast we had to do it, but it eventually we worked most of these things out. But this is also not the world we live in, right? We don't live in the 2020 world anymore, right? So when you're going to be teaching, or at least if you think about developing teaching materials, right? You want to think from the beginning in terms of a hybrid world, right? Because even if you're going to be all remote or all in person, then you probably want to collaborate on some of these materials with people who will be using them for the other stuff. And your own classes might be hybrid, right? Or might not be, but even if you're all in on one of the things, you want to be in a place where you can easily collaborate with people who are doing the other things. Right, so you want to be able to develop materials for both in-person and remote, and there is a thing that's always been there, right? Like the third form of teaching that we also had since the more or less beginning of time, which is self-paced, right? When I was a kid, we used to call it workbooks or whatever, right? But you hand stuff to students and they do it on their own, right? Hello, Kitty. I walk around a lot, so I might have not noticed that I kind of almost stepped on it. That's okay. Right, so, I don't like to use the term homework because that's very loaded and very controversial, but, that's at least the image you should have in your head when I talk about what I mean by kind of self-paced work. So when we teach, we use words, right? So we often have teaching materials that share text. It might be a lot of text, right? Right now I am sharing text, right? It's just 2 words and then I'm speaking a lot, but these 2 words are useful, right? They kind of ground, what I'm going to be talking about. And specifically when we have text, part of it will be contents, right? The word contents appear on your screen, so you know that I'm going to be discussing a little bit about textual contents. And the other thing that we do when we share text is we also have formatting, right? I made sure that the words contents and formatting are in separate lines. That was very crucial to the presentation here, otherwise it would be confusing about what I'm talking about, right? So this is a big part of teaching, right? But I'm sure you know where I'm going with here. In modern teaching especially, we like to use visual aids, right? For obvious reasons. We're, in general, very visual creatures, right? Images are useful. There is even a cliche, right? I don't think I have actually managed to shove 1,000 words. I kind of tried to play around with like font sizes, but they got cut off. And so you see exactly how much an image is worth. It's actually hard to shove 1,000 words into an image. And last but not least, there's interactivity. And again, this is not a new thing, right? Like hands-on teaching has been there from the beginning of time, right? After you teach someone, you know, kind of the theory of driving, you have them get behind the wheel and actually, like, you know, move a wheel and ideally, like, you know, move the car in reasonably correct ways, right? And when I talk about interactivity, right, that means that, like, you know, you might be changing, like, the inputs. You're doing something, right? So, you know, you might have a slider, and when you change it from, like, say 4 to 7, you'll see different outputs, right? So now the font will be bigger, right? So this is like the core of interactivity, right? You do something and you see how it changes, and that teaches you something useful about the subject matter, right? Like, you know, this is a useful demonstration if you want to give people a good visual about, like, you know, what font sizes mean in, like, you know, if you're teaching them about formatting or something like that, right? So this is important, right? Like, you know, all these things, right? Sharing text, sharing visuals, and giving people some interactive thing to play with are important parts of how we kind of prepare teaching materials. So now we've kind of hopefully all aligned on, like, you know, what things we want to do when we teach. So let's talk a little bit about Jupyter. I know how many of you have used Jupyter before. I'm always surprised that, like, you know, people use Jupyter less than I thought. So I want to kind of give a quick breakdown. The main thing people associate with Jupyter is a notebook, right? The notebook is where stuff goes, right? But notebook by itself is just, like, you know, kind of a file, right? It has contents and like some way to present it, right? But the cool thing about Jupyter is that it has the interactivity built in, right? The notebook can have code cells, and so something needs to execute the code cells. And unfortunately, like, the word kernel might be the most overused word that I've ever heard in, like, CS and math, right? There's like 5 different things called kernels in math, and there's like 5 different things called kernel in computer stuff, which is somewhat unfortunate, but the thing that executes the code cells in Jupyter is called the kernel. That's going to be important later, so probably best to get it out of the way. So if I say the word kernel, you know, I'm not talking about, you know, how to install the new Linux. And in that notebook, there are different kind of cells, right? Like, some of them will be code cells, some of them will be markdown cells. So you can have cells that are purely markdown formatted, and you can format the text however Markdown allows you. And because Markdown basically backends into HTML, you have arbitrary formatting capability. So that's pretty cool, right? Like, we're, you know, you're gonna see how this is gonna be relevant later. When people originally envisioned Jupyter, teaching was not the main goal. It was mostly for, like, exploratory programming stuff, but also, like, there was still, because if it was just exploration, I'm not sure that, like, you know, they would have gone beyond the IPython. One of the benefits of, like, you know, kind of moving from IPython to Jupyter was that it enabled better sharing, right? So, you know, if a data scientist, you know, finishes the exploration and reaches some, you know, kind of important insight, they have the notebook as an artifact they can share with their colleagues or friends and kind of, you know, basically share knowledge. And if you think about, again, like what I talked to you about teaching, you notice that these things are, you know, very similar to, like, the things we need in teaching, right? We want people to explore stuff, and we want to share stuff with people. So this is great. Okay, so if we do want to have people explore, we'll need to give them some Jupyter. There are a few options to install Jupyter, and I want to talk to them again in the context of teaching people, right? That's like the default, right? You know, get a Python environment somehow installed on whatever computer you're using, and then, you know, do enough pip installs and enough setup so you can use Docker. There's like 50 million variations. And this is a great option, right? Like, again, you know, we're here in Petaluma, like, outside kind of like, the main part of the city without great internet. Clearly, this is really awesome to have everything running locally. Again, especially in the context of teaching, one of the problems that you run into when you have people install Jupyter locally is that you'll write instructions, and about 50, if you have some experience in writing instructions, about 50% of the people that you're going to teach will follow them, and this will work great. Some amount of people will run into problems. So once you kind of like, get some feedback about your instructions, you add like a troubleshooting section, and then 25% of people will run into one of the problems that you've kind of aligned, and they will fix it. There's like still kind of 10% really weird edge cases, and you'll add some more kind of like, if that didn't work, here's a few kind of hacks to kind of try out. And, like you'll try more and more, and in the typical case, you'll have like the 1% that like, you'll never manage to figure out, right? Like someone managed to like use like a really old version of Mac, or like a hacked up installation of Windows, which is like, like weird firewall rules, or like something like that. So local works great, especially if you own all the computers and you can kind of pre-install image, but that's like, honestly, like such a utopian scenario. I've never encountered that. It has, but obviously, like the benefit is that it just runs locally, and once you get it to work, it works very reliably. The obvious alternative to local is remote, right? You can use something like JupyterHub. There's approximately 50 million ways to configure that. I'm definitely don't have like that would be like 3 talks on its own, so I'm definitely not gonna have time to kind of dive into the details of that. But you can have basically like, and the nice thing is that it behaves kind of post-installation and or setting up the network connection the same way, right? Like you open it in your browser and everything looks the same. So you can have some of the people use remote and some people use local, and it's feasible. Obviously for remote, you have to figure out how to network and how to pay for that, and like how to manage that. So both options are on the table. You'll have to decide what works in your particular situation. But there is one last option that is very important, although of course it does come with its own trade-offs, and that's JupyterLite, which is again something that I'm always shocked by, less people knowing about it than I expect them. JupyterLite is a Jupyter that runs in your browser, right? So it's not running in a server with your browser looking at it. It like runs actually inside the WebAssembly environment inside your browser. So that's very, very simple to install because you click on a button, right? And again, if you have a limited network situation, you grab the file, you host it locally, and people click on a button, right? Or you have them do that beforehand, and it caches in the browser, right? So the installation process is, to a first approximation, completely trivial. But, right, obviously, like, if it was perfect, I would have talked about it first and said, like, don't worry about the other option. There are all kinds of limitations. The WebAssembly environment is weird, right? It doesn't have processes. It doesn't have, like, it has some things that look like files, and some of the file APIs will work, and some of the file APIs won't work. And some of the threading stuff won't work, right? So you can like the networking stuff definitely won't work, because from inside the browser all you can do is use fetch. So if you import requests, even though request does HTTP, it assumes that it needs to open a TCP connection, and there are no TCP connections from the browser, so a bunch of things won't work as you expect. However, if it does work for you, this is a great option. So it's important to kind of think about your options and to kind of try it out. Then, if you have a notebook and you are going to do what I'm doing right now, which is kind of teaching in, in front of people, right, and not having people do self-exploration, you'll want to convert the notebook to some format for presentation. This is a great place to be in, because you are like, it's like there's like a lot of options and a lot of great options. You'll probably some of the time you'll want to convert it to HTML, which is a great option, and like, it has out-of-the-box conversions to HTML that work just fine. You can convert it to PDF, which also works fine, and you have a few options. There's like even built-in slide support, so you can like export it into something that's like basically like backed by Reveal.js. So if you use that works great too. But you also have other options if you want tighter control of your output. because nbconvert is to a first approximation magic. It has really great programmability into like, what you can support, right? You can hide certain cells completely. Again, if you think about pedagogical values, that's really important, right? Sometimes we don't want to show people stuff that will distract them. You can hide the output of a cell, which means if you're showing people code and you're calling a function that returns something, then that return value will be in the output, and sometimes it will be like, just like a number that is not relevant, right? Like when you write to a file, it returns the number of characters you wrote. But that's probably boring to your class if you're talking about, kind of file access. So you can hide just the output. And you can also do the reverse. You can like keep the output and remove the input, right? Which means if you wrote complicated code to kind of auto-calculate like a very nice graph that shows, some point that you're trying to get across, the code might be a distraction, right? You want to show the graph and focus on the graph when you're teaching, so you can hide that. And of course, on top of that, you can build like really nice conversion pipelines. So usually the way it works is you do the first pass with nbconvert, and you use some of that programmability to kind of decide what to hide, what to show, what to kind of post-process. And then you use pandoc as a second step to kind of take the markdown and convert it to like, one of the approximately 5 million formats that pandoc supports, which is a great. And again, pandoc has a lot of features. And if you make your notebook with proper care, you can use that to do all kinds of cool stuff. In fact, that's more or less how this presentation was constructed. It's a Jupyter notebook, nbconvert to markdown, then I do pandoc to convert it to LaTeX, and then I do some other weird stuff to produce a PDF out of it. And it's pretty cool, and you can see that in it work if you look at the repository. And it's source control friendly. It's reasonably source control friendly, right? At least compared to like, other options of preparing presentations, right? Say using like, Google spreadsheets or Microsoft Slides or whatever it's called, Present. Those things you can shove into source control, but that's definitely useless. You won't even see the diff reasonably well. With that, yes, like there will be some spurious diffs. Mergers are definitely the opposite of fun. You can play around with it and clear up that stuff, because like, for example, like the number of the execution will be there, but there's like tricks around that if you really care about these things. But even if you do nothing, at least it's reasonably source control friendly, or at least see the diffs, right? So that's pretty good. It's basically a JSON file. Like I said, the mergers can get a bit unpleasant. And if you want to share the notebook, again, you have a lot of options. More source collaboration kind of Forge's platform, right? GitHub, GitLab, Bitbucket, probably a bunch of the open source ones. They support rendering. As you just use the notebook online, the same way they render Markdown, they'll just natively render the notebook. This is really nice because you can just give people a direct link to the source collaboration, and unless they want to further interact with the notebook, they can see it. And even if they want to, this gives them like a first pass of like making sure that this is a file they actually wanted to download, right? If they want to download the exercise 1, not exercise 2, at least they can see that this probably matches up with the expectation. So the rendering is pretty good. If people need to read it, right, you can kind of have even the reading experience be a bit more interactive, which is always useful because people can kind of just get distracted by boring really big. So you can have like inline cells that get rendered kind of, and you kind of acknowledge that they read it. You can render code really nice. You can put even custom widgets so that they'll kind of like mark they read, or even like more complicated stuff like what do you think was the main point of the paragraph, even if it's not for you as a teacher to consume, even if it's just for them to kind of guide them about what to think, how to think about this paragraph, right? If you gave them like something and you kind of tell them like what do you think was a critical year in which kind of like that event happened, right? Like then you kind of guide them on like what they need to read the text for, which is very useful. And if you want to give exercises, right, again, notebooks give you a lot of options, right? You can literally put kind of empty cells and say, you know, fill this cell with like your answer to stuff, and then, you know, save the notebook. Or again, you can use widgets, right? So you can, you know, put like kind of a multiple choice radio button, you know, which of these options do you think is correct, right? Like, you know, what should be the answer, and have them click on that. Or, you know, again, text input buttons, or, you know, checkbox, or like, you know, other kind of options. And if you do want to do automated verification, again, like, you know, you're in Jupyter, you can do whatever you want. So if you do have something that's machine checkable, right? For example, like a number that you can decide if it's correct or not, then you can decide that number. Or, you know, obviously machine checkable is a way to kind of transform kind of free text answers into something that would be more machine checkable. So the student can get immediate verification. Did I get the material so far, or do I need to read further, or, you know, back, or do I need to ask for help from the teacher, right? So you give the student immediate feedback. Of course, you know, computers can do everything. We just had a short discussion before the talk about how, you know, there's like limitation and something still are best done by humans, right? You want to have an opportunity for teacher feedback, right? Again, I'm avoiding to using the word grading, because, you know, a lot of modern teaching methodologies downplay, you know, what we think of as grades, but grades are a form of feedback. So if you've never encountered, like, you know, different kinds of feedback, you can have grading as kind of a metaphor for what teacher feedback means. So if you save the cells, right, if you fill in cells and save them, you can submit the notebook, right? And the teacher can kind of import the notebook and check it for, you know, correctness and whatever feedback they want. You can inline submissions through an API, right? So you can kind of have the widget that after you click, and you click, like, you know, kind of, this is like the answers I want to submit, and it submits it to, like, you know, whatever LMS you use locally, right? You can integrate it into that API, so they can submit it, and again, the teacher will grade it later. So after I kind of try to sell you, hopefully, on like why you should integrate Jupyter into whatever teaching you do, I do want to acknowledge some of the limitations it has. If you do decide to go with remote, server setup can be non-trivial, right? Your local IT at a small college can't probably handle that, right, easily. Right, obviously, if you have a bigger IT team, then you have other issues, right? You probably have to go through approval process for new server. So, you know, like, either way, this is not an easy thing to do. And JupyterLite, a lot of the things that you would do are still limited. Some, you know, I kind of try to kind of cover the main limitations as like in the weeds, tons of other things that still can't be done. But I think even with all these limitations, there's still like significant advantage. This is like a platform with really powerful tools, right? Like we can do a lot with Notebook, right? We can manipulate them, right? We have Python kind of, you know, things like, you know, especially if you, again, like, you know, use nbconvert and nbconvert plugins, you can do a lot of stuff. Like you have a good platform for tooling. And even more important than the tooling we have is like the tooling we'll have in the future, right? Jupyter is a popular thing. A lot of people use it, right? Not many people use it for teaching, but people use it a lot, right? Which means people are always developing new tools, right? There's like, you know, Binder, right? Which I haven't even talked about, right? And like, you know, the ecosystem keeps growing. This is a great time to get into the ecosystem, see what stuff, you know, the new ecosystem has for teaching, and collaborate with other people who are using Jupyter for other reasons, and see, you know, what more things we can add to that ecosystem. So these are the early days, right? Which means, like any good technology that you're going to use when teaching, there's not a lot of, you know, many other technologies. You might have like at least someone who kind of used it for like, you know, 10 classes before and can tell you like, you know, all the pitfalls. People are not using Jupyter for teaching a lot, right? This is why I get to give a talk about that. But this means that, you know, if you integrate it into your teaching, you will make mistakes, which is fine, you know, just, you know, I want to acknowledge that, right? But that's fine, right? Hopefully you'll learn from your mistakes, and, you know, you'll fix them and do better and acknowledge that, right? That's the flow we all go through, right? But again, hopefully we'll share, like, whatever worked and didn't work with you for Jupyter, and whatever, kind of teaching collaboration kind of, spaces we have, right? There's a great podcast called Teaching Python, right? There's like other great places we can talk about teaching, especially for teaching specific subjects. I'm sure if you're in this space, you already have some spaces to talk about that. And, ideally learn and, like, kind of iterate, do better, and kind of go back to the beginning and ideally make, different mistakes so you can learn from those. So that's kind of my call to action, right? I think Jupyter is a really good technology to kind of add in your toolbox for teaching for the 2020s. It definitely has the option of making your presentation a lot more visual, more interactive, right? It has interactivity kind of built into its bones, right? And it supports a lot of really powerful flows, which give you like a lot of room to play with. So that's it. Thank you very much. Feel so fortunate I had the time to kind of talk to you about that, and I hope that this will help you teach better. Thank you so much.
Okay.